Hello ladies and gentlemen, and welcome back. This is Algebra 2 from Prospect Charter School, and this is going to be section 1.4, Simplifying Algebraic Expressions. So from the previous lesson, we know what an algebraic expression is. An algebraic expression is a set of terms that have both constants and variables. So what we are going to do is we are going to learn how to combine them and how to work with them, because not all variables are the same. In fact, we have some special rules when dealing with these variables. So let's go ahead and jump straight on into what we are allowed to do and what we are not allowed to do. So the first thing that we need to know of is the parts of the term. So for an example, 2x. The whole thing is called a term. 2x, the whole thing is a term. The whole thing is a term. Now, the first part of it, the 2 is a constant. So the 2 is called the constant or the coefficient. And then the second piece, the x, is called the variable. So the whole thing is a term, the 2 is the constant or coefficient, and the x is the variable. Next up, let's try to see what happens when we have two things of two different variables and two things of the same variable. For an example, if I was looking at 4x minus 2x. Now I note that the coefficients are different. One coefficient is 4, the other is -2. But the variables, x, are the same in both terms. This is what is called like terms. So let's write that down. If both variables are the same, then they are like terms. Meaning that they are alike. So because we have 4x, x is the variable, and we have 2x, x is the variable is the same in both cases. If they are like terms, then we can combine the coefficients. So in essence, we kind of ignore that the x's are there, and we just look at the coefficients and say, okay, what is 4 minus 2? Well, 4 minus 2 is, of course, 2. And then the variable, the x, hangs around. It doesn't change at all. So when we're looking at addition, the variable doesn't change, but the coefficients can. So in this case, we had 4x minus 2x to give us 2x, just as 4 minus 2 gives us 2. Now let's look at another case. Let's look at 4x plus 2y. Since the variables x and y are different, we cannot combine them. So what we would say in our justification is already simplified, and of course I misspelled already, simplified since they are not like terms. Are not like terms. So we can't do anything. They remain separate because they are not like terms. It's like trying to add apples to oranges and get apporanges. It just doesn't work. You have apples, you have 4 of them. You have oranges, you have 2 of them. And you cannot have 6 apporanges. So next up, let's take a look at working with some other terms. For example, what happens if you have more than one variable in a term? So let's say that we have 2x plus 3xy, or just plain old x plus 3xy minus 2y. And we are going to be given some information. We are given that x is equal to 4 and that y is equal to 7. Now, we note that the variable can come in many pieces. For example, this one, x times y, is still a variable. And the only way we would be able to combine it with the others is if they have both x and y in them. This one has x, but since it doesn't have y, we can't do anything with it. This one has y, but since it doesn't have x, we can't do anything with it. So none of these three are like terms. So we can't simplify it before we do the evaluation, which would be the plug and chug. So let's go ahead and try that plug and chug. So x's I'm going to use pink for, and then y's I'm going to use green. So we have 1x plus 3x y minus 2 and then y. Now note how I start this out. I start out by putting parentheses for where every single thing that I plug in. This is the same thing as the plug and chug from the previous lesson, but it's a good habit to be in. So I note that the x is equal to 4, so every time I see a set of pink parentheses, I put in a 4. And y is equal to 7, so every green set gets a 7. Now I can do the order of operations normally. So I'll have 4 plus 3 times 4 is 12. 12 times 7 is 84. So we have 84. And then negative 2 times 7 is negative 14. And then I'm going to do the 84 and 14 first. So 84 minus 14 is 70, plus 4 is 74. So when we're working with these, the first thing to make it easier would be to combine as many terms as you can. Unfortunately, we didn't have anything that combined here. All of them were unlike terms, so we couldn't do anything. Next up, we do the plug and chug in. We plug them in. First, we write a parenthesis for every type of variable, and then we plug in the correct variable to the correct locations. After we're done with that, that's when we can finally come to a numerical answer at the end. Okay, let's take a look at another one and see what happens with it. Let's say that we have b squared z minus 2bz. No, we are not too busy to get to work. Plus z squared. And we are told to, if I can write a plus sign here, and we are told to evaluate it for b is equal to 6 and z is equal to 2. So we're given that b is equal to 6 and then z is equal to 2. Now, once again, I would love to do some combining of like terms. And we notice, hey, there's a b and a z here. Oh, look, there's also a b and a z here. But we still can't combine them. Now, why do you think that is? Well, if we take a look at the b, this one is being raised to the second power, while this one's only being raised to the first. So they aren't identical. And if they're not identical, they're not like terms. So because the b is raised to a different power, they are unlike terms. We cannot combine them, which means that we have to go straight into the plug and chug portion. So b is 6, so I put a whole bunch of parentheses for all the b's, and another one for all the z's. So I have b squared z, so I'm going to put a little squared here, b squared z minus 2b z, and then plus z squared. So plus z squared. And then I put in a number for each variable. I know that my b's are all 6, so wherever I see blue, I put a 6. So I put a 6 here and here. For z, z is 2, so I put a 2 in every red spot. Here, here, and here. Now I do my order of operations. 6 squared is 36, so this becomes 36 times 2 minus 2 times 6 times 2, and then plus 2 squared is 4. Now I do the multiplication. 36 times 2 is 71. Nope, 72. Yeah, 72. And then we have minus, let's see, 2 times 2 is 4, 4 times 6 is 24, and then plus 4. Now I note that there's a 4 here and a 4 here, so those are the ones that I want to combine first because they cancel each other out. So then I have 72 minus 20, 7 minus 2 is 5, so then I just have plain old 52. Alright, so note what we tried to do. We tried to combine like terms first. Doesn't always work. Then we plug in the numbers that we are given, do the plug and chug, and move on. Now, what happens if we do have like terms? Well, we can combine them first, and that might make life a little bit easier. So let's look at a case where we actually do have some like terms. Let's look at x squared plus 5x plus 2y plus 7x squared. Plus 7x squared. And let's say that we are given nothing for the variables. We don't know what the variables are. Okay. So in this spot, the first thing we want to do is find like terms. So is the x squared and the 5x a set of like terms? The answer to that is no, because we have squared versus 1 power. So they are not like terms, we cannot combine them. What about the x squared and the 2y? Well, that one's pretty obvious. Y's and x's are not the same thing, so that doesn't work. And what about the x squared and the 7x squared? Yes, those are like terms. They both have the variable of x squared. So we would combine them. Now when we combine them and we don't see anything in front, we can think of it as an invisible 1, because a 1 is super thin, and if it was to turn onto its side, it would become invisible. So we can say that there's a 1 in front of the x squared, and there's a 7 in front of the x squared. So we go 7 plus 1 gives us 8. So we have 8x squared. Is there anything that our 5x can combine with? No, so we just bring that down, and we say, okay, plus 5x. And then the last one, is there anything that we can combine with our 2y? And once again, there isn't, so we just bring that down. None of these are like terms, and so we are as simplified as we can possibly get. All right. Well, that is it for this particular lesson. Next up will be, of course, our practice problems. So our practice problems are going to be in the textbook. They are going to be section 1.4 on page 31, and it is going to be numbers. Actually, it starts on page 30, not 31. My apologies. And we're going to look at 1, 5, 9, 11, 13, 15, 19, 21, 23, 25, and I know it's an even number, but I really want us to get used to doing word problems, so I'm going to include the even number 26. Word problems are really super mega important, especially considering the smarter balance tests that we're going to be taking here soon. They're all word problems, and you have to get really good at showing how to do word problems. I'm going to make a special video dedicated purely to word problems, just like we had a special video dedicated purely to learning how to take notes. There. In the meantime, you have your assignment. So, get to it, good luck, and have fun.